Mm. Hello everyone. Good morning to all of you. Again, welcome back to LNT College Multimedia Studio, Muzaffarpur. Today, we are entitled to focus on the highlights of alkaline earth metals. Right? So, highlights means they are derived from halogens and it contains X minus, right? So X is a suppose uh, halogens like fluorine, chlorine, bromine, iodine, right? So this X may be fluorine, chlorine, bromine, and iodine, right? So if these non-metals receives one additional electrons, then it is converted into um, halide ions, right? So this is negatively charged halide ions. So the halides of alkaline earth metals, actually alkaline earth metals like beryllium and magnesium and calcium is strontium, barium and radium. As in the previous lectures we have dictated very clearly about the alkaline earth metals and its characteristics. And as you know that all the alkaline earth metal actually they exist in their plus 2 oxidation state. So because of the noble gas configuration of the resultant charged cations. So in plus 2 oxidation state they form a compounds so with halogens, actually by direct reaction with halogens they form ionic compounds, and the compounds they actually forms it is actually like you can say, suppose we have a metal, so that is M denotes any other alkaline earth metal, right? So then if it direct heated in the presence of uh, halogens, right? So it forms a compound like MX2, right? So once this alkaline earth metal react with halogen to form a compound so that contains MX2 structure, it means so it exists as M2 plus and 2X minus, right? So 2 plus and 2 minus, so there is a large electrostatic interaction between two species. So it forms MX2 type of ionic compounds. So in general, all alkaline earth metals they actually react with direct by halogens to form MX2 type of compounds. Because of the high electropositive characters of M2 plus, right? So it will react with more electronegative halides. As you know that in the halogen family, fluorine is the most electronegative element which has electronegativity. So that is exactly 4.0, right? So in case of fluorine, electronegativity is very high and it is the most electronegative element in the periodic tables. So larger the electropositivity of a metal cations, it will prefer to react with highly electronegative elements. So such type of cations actually prefers highly electronegative elements. So that is why they form halides. And one more aspect is that uh, because of the electronegativity difference, so in case of suppose we have a beryllium, so beryllium has 1.5 electronegativity, right? But in fluorine, suppose fluorine, or you can say simply chlorine has 3.5. So overall, the difference between these two electronegativity as 2. So it is greater than 1.8, right? So if the difference of electronegativity between two metal and non-metals is greater than 1.5, it indicates highly ionic behaviors. So all compounds possess ionic behaviors, and because of formation of ionic compounds. But in case of beryllium, beryllium is actually a metal which possesses some anomalous behavior. So because of the its small size and high charge density as a Be2 plus, right? So it is actually very small and contains high charge density because of presence of plus 2 charge. So as you know that uh, small and highly charged cations has actually more polarizing powers. So they can polarize the electronic clouds of halide anions, right? Suppose you have a halide anions like X minus may be Cl minus, right? So this Cl minus has actually electronic clouds because of presence of electrons in the valence shell. So this small and highly charged beryllium cation, actually they will attract the negative charge density or electronic density towards itself. So they will distort the structure of this chloride ion, and hence it forms actually covalent bonds. So Be forms a covalent bond with halide ions, and this is primarily because of the actually highly charged cations and negatively charged halide ions. And you know that, so as the size of the halide ion is larger compared to the size of the beryllium 2 plus, so a small and highly charged cation, that is beryllium 2 plus, will polarize effectively to the halide ions, and hence there is a chance of formation of the covalent bond. So beryllium compounds mostly they are not purely ionic, rather it forms covalent compounds. So BeCl2, suppose if it forms BeCl2, then this BeCl2 is not purely ionic compounds, rather it possesses some sort of covalent characters. And apart from the beryllium, rest of the other metals like magnesium and calcium, strontium and barium, they form really ionic compounds. So what is happens here, actually suppose we have that is magnesium, and this is your beryllium, magnesium, calcium, strontium, and this is your barium, right? So because of the anomalous behavior of beryllium, and in this state rest of the other metals, actually magnesium 2 plus also actually is small compared to the rest of the other metal. So this magnesium 2 plus also favors some sort of covalency, and hence it forms a covalent compound. So from this particular groups we can infer that beryllium 2 plus and magnesium 2 plus, these two species, and because of the small size and high charge density, they form covalent ionic compound, right? Covalent ionic compound. But rest of the other metals like calcium, strontium and barium. So these three metals, radium, here radium, you are not going to consider radium, so because of its short life radioactivity and the products are not stable at ambient temperature, so radium is not considered here. So rest of the metals like calcium, strontium and barium, they forms actually such a compounds. Suppose we have a halide ions like chlorine, which forms halide, that is chloride ion. So CaCl2, SrCl2 and BaCl2. So overall, if all these metals forms BeCl2, MgCl2 and CaCl2, SrCl2 and BaCl2. So these chlorides, beryllium chlorides, magnesium chlorides and calcium chlorides, strontium chloride and barium chlorides. In this particular halides, barium chloride and magnesium chlorides, as you know that once moving from beryllium halides to barium halides, what actually happens, the size of the cations actually increases, and here chloride ion is common for all the metals. So because of the size effect, so lattice energy decreases in case of these halides. So BeCl2 must be highly soluble actually in ionic solvents, but because of the covalent characters, so it is soluble in covalent or non-polar solvents like benzene, ethers, and some extent solubility decreases in this group because of the poor hydrations. So BeCl2 is actually because of the Be2 plus. This is highly charged species and it has high tendency to remain in hydrated state. So Be H2O4, right? So this beryllium actually exists in the water as a hydrated ions, that is BeH2O whole 4. So here coordination number of beryllium is, that is or you can simply say 4, or hydration number is 4. So this beryllium actually forms when it in halide, then beryllium chloride, and this beryllium chloride, because of the covalent character, they are soluble in most of the covalent solvent, ethers or any other benzene like solvent. But rest of the magnesium chlorides and CaCl2 and SrCl2, BaCl2, all these compounds are soluble and solubility decreases as you move from top to bottoms, as the hydration number decreases from top to bottom. So most and highly hydrated beryllium 2 plus, so it is highly soluble. But in case of beryllium chloride, BaCl2, so it has low lattice energy although, and it has also low hydration energy because of the large size of Ba2 plus. So this Ba2 plus does not hydrated much more. So or simply you can say there is a less number of water molecules surrounded to this particular barium cation, right? So solubility decreases. Then the question is how these halides are prepared. What are the process? What are the synthetic process that by which we can prepare the halides? So here are simple methods, some simple methods that which we have supposed to be adopt for the synthesis of that particular alkaline metal halides. So as you know that beryllium 2 plus, because of the hydration, so they exist in the tetracoordinated aqua ions, so that is BeS2O का whole 4, and that is balanced by counter anions, that is 2 chlorine atoms. Once this compounds is heated, it forms beryllium hydroxide. Means this tetra-aqua coordinated beryllium so undergo hydrolysis, and if this is heated, so it forms beryllium hydroxide in their +2 state, and hydrogen chloride is actually released from the structure, right? So this is not the proper way to develop beryllium chloride, but this beryllium oxide once react with ammonia in the presence of hydrochloric acid, so it forms diammonium tetrafluoroberyllium, right? So once this compound, actually this is a complex compound, once it is heated, it is decomposed to form beryllium fluoride and ammonium fluoride. So this is a type of halide, that is beryllium fluoride. So similarly, magnesium fluoride and calcium fluoride, and magnesium fluoride, calcium fluoride, beryllium fluoride, and strontium fluoride, so can be obtained through this particular reaction route. Now another terminology is that, so that is beryllium oxide of 2 mole here in a non-polar solvent, that is carbon tetrachloride. So once it is reacted at 800 degrees centigrade, it forms beryllium chloride, and by releasing the carbon dioxide gas, right? So this is similarly, this is beryllium oxide that react with carbon in presence of halogen at a temperature of 700 degrees centigrade, that forms beryllium chloride and carbon monoxide. So depending on the suitability and the concentration of the as a major products, we can select the methods to obtain actually alkaline earth metal halides. And in general, all the metal so they react with halogen acid so to form, that is actually metal halide. So M is for actually any of the alkaline earth metals, and X may be either fluorine, chlorine, bromine, iodine, like that. And so because here you know that this beryllium chloride obtained from this technique, this beryllium chloride react with water, so they undergo hydrolysis and to form beryllium hydroxide by releasing hydrogen chloride acid. So beryllium and magnesium chloride, similarly you can say MgCl2, they react with water, so it forms MgOH का whole twice plus 2HCl, right? So this magnesium chloride and beryllium chloride undergo hydrolysis in the aqueous medium to form beryllium hydroxide and magnesium hydroxide, right? So all rest of the other halides like calcium and strontium and barium halide does not undergo hydrolysis. They form almost purely ionic compounds because of the size effect and stabilization of the halide ions with larger cations. Now suppose we have a that is if we have a calcium fluoride, a special type of actually metal halides, once they react with sulfuric acid, right? So this reaction will produce, that is hydrofluoric acid, and that is calcium sulfate, which is a ionic compound. So this is soluble, and these hydrofluoric acids are most important for the production in particular ionic halides. Now this hydrofluoric acid will react with potassium fluoride to form a complex structure, that is potassium hydrogen fluoride. Similar to potassium triiodide, it forms a complex like that. So you can simply say that upon electrolysis of this complex compound, actually it forms fluorine gas. So calcium fluoride is a great source of actually for the hydrofluoric acid. This is most important in the glass industry, and this is the for fluorine gas, right? Now what is actually you say, once the halides are formed, or you can say once the MX2 type of compounds are formed, so apart from the beryllium halides and magnesium halides, so they actually show white fumes in flame test, and rest of the other halides, suppose we have calcium chlorides and strontium chloride, right? So this is barium chloride. If these salts are heated in the flame, so what is actually happens here, they absorbs, all these halides actually absorb visible electromagnetic spectrum, and they actually emit brick red color, and similarly strontium chloride will emit crimson color, and barium chloride that emits grassy green color. So because of the flame characteristics and color characteristics, all these halides like calcium, strontium and barium chlorides, so they are actually used in fireworks to create a different color in fires, right? So this is the actually beauty of such type of actually metal halides, right? Now we come across the structure and bondings. So if beryllium, suppose we are interested to beryllium chloride, right? So once the beryllium chloride is manufactured or synthesized in the laboratory, then the question is, what is structure of this particular compound? So beryllium chloride actually it exists in the gaseous state. So like BeCl2 as whole twice. So this is your dimer, right? So actually this beryllium chloride exists as dimer in gaseous state, right? But because of the volatile nature, beryllium chlorides are actually volatile compounds. So once this is volatilized and this is monomerized to form beryllium chloride, right? So this has a actually linear structure, and linear structure, right? So this is the actually structure BeCl2, and this is your Cl, right? So this is the structure where actually two covalent bonds are formed, one covalent bond and second covalent bond. So this is your structure in the vapor phase. So this is actually exist in vapor phase. So gaseous phase exists as dimer, whereas vapor phase exists as a simple monomer, that is BeCl2. But once it is freezes or temperature is lowered down, this gaseous structure actually form a network like structure. So that is actually BeCl2 ka whole n. So this is polymeric. This is your polymeric compounds. So this is exist only in solid state, right? So what is the structure of this particular halide in solid state? It forms a polymeric chain. So that is actually beryllium. So this is your Cl and this is your Cl. Now another beryllium. So they are condensed to each other, right? So similarly, you can draw another structure. So they are actually polymeric solids. So they are linearly flowing their structure, and it has actually halogen bridge. This is chloride bridge, right? This is your chloride bridge. Chloride bridge. It also three-centered, right, bonds, that is BeCl-Be, right? BeCl-Be. So it has also three center bond, right? But because of presence of halide ion, this is halide ion, and actually it forms one covalent bond, and this is also, and this beryllium also form one covalent bond. But because of the presence of lone pairs on that particular chloride ion, they actually donates its lone pair. So it forms coordinate bond. And similarly, the chloride ion below the plane, this also donates its pair of electron, right, to another beryllium. It forms a coordinate bond. Coordinate bond. So in this structure, right, two halogen bridges are formed with a three center bond. Means there is two covalent bond, right? So this is also a covalent bond. This structure appears like that. Similarly, because of presence of vacant orbitals in this particular beryllium, it polymerized with another nearest beryllium chloride. So it also forms a simple, that is covalent bond, and this is your coordinate bond, and again another beryllium that forms a covalent bond, and this halide ion forms a coordinate bond. So each beryllium is surrounded by two coordinate and 2 covalent bond, 2 coordinate and 2 covalent bond, and they are tetrahedrally surrounded, right, by 4 bonds. So it means now this beryllium actually possesses complete octet characteristics. So the octet is complete. It means beryllium is now supposed to be stabilized by covalent bond and coordinate bond. So this is actually bridged structure which exists as polymeric form in the solid state. So this structure is somewhat different from the as previous lecture we have actually given the structure of beryllium hydride, right, in polymeric form. So that is actually BeH, this is H, and now this is beryllium, and this is your beryllium. So this is your beryllium hydride, but difference is that here this hydrogen exists as hydride ion, but because of the small size of that hydride ion and unavailability of lone pairs, so it actually does not form a covalent or coordinate bond. So this is also 3-centered bond, right? 3-centered bond, 3-centered bond, right? But the hydrogen that is hydride and it exists in the above of the plane, and another hydride ion exists as below of the plane. So once they form a bond with hydrogen, right, and this beryllium forms hydrogen, there is unsaturation on each beryllium centers. So what happens? This hydride ion, which has 2 valence electron, so it has 2 valence electron, right? So these 2 valence electron will stabilize to all these centers, like this is your beryllium, so that is stabilized, and this beryllium is also stabilized by these 2 electrons. Means 2 electrons are mobile, right? They are delocalized on these 3 centers. Similarly, 2 electrons are actually delocalized on 3 centers. So 3 center 2 electron bond it forms, and in the polymeric structure is each beryllium is surrounded by 4 bonds, and actually they have unique bonds. So you can't say they are perfect covalent bond, but there is a type of a special bond that is called delocalized bond, and because of the delocalization of the hydride anions or its electron, so here also bridged structure, but coordination bond is absent in this particular structure. But in case of beryllium halide, so there was coordinate bond. So this is the difference between actually the beryllium hydride and beryllium chloride. So here beryllium also tetrahedrally surrounded, right? And similarly in beryllium chloride also beryllium is tetrahedrally surrounded by covalent and coordinate bonds, but beryllium is actually surrounded by some pure covalent bond and some delocalized covalent bond. So this is the actually structure of beryllium hydride in the solid state. Now some other implications of the actually metal halides, like suppose water of crystallization, या crystallization of water, crystallization of water, right, in halides. Suppose we have a halides like BeCl2, MgCl2, calcium Cl2 and strontium Cl2, and that is your barium Cl2. Suppose we have a halides like beryllium chlorides. So this beryllium chloride are actually, all these compounds are actually hygroscopic in nature. So they absorb moisture from the atmosphere. So it accepts water molecule in the lattice structure. So because of the hydrolysis, this beryllium chloride once react with water, they actually forms beryllium hydroxide. So the water of crystallization actually in this particular structure does not look like that, like MCl2. So this is actually MX2 into XH2O. So this XH2O indicates the number of water molecules that stabilize the lattice structure of this particular halides. So in case of beryllium chlorides, because of the fast hydrolysis of this particular compounds, H2O molecule does not remain in the lattice as crystalline water. So rest of the other halides like magnesium chlorides, calcium chlorides, strontium chloride and barium chlorides, this compound magnesium chloride actually it forms MgCl2. It contains 8 H2O, right? 8 water molecules, 8 crystalline water molecules are actually stabilized in this particular lattice. So in this case, CaCl2 it forms 6 H2O, right? So SrCl2 it may be 4 H2O or 6 H2O or 6 H2O depending upon the type of lattice structure. And similarly, this compound BaCl2 it only accommodate 2 water molecule. So in simply you can say that the number of water molecule or hydration number decreases from moving magnesium to barium because of the size effect. So magnesium 2 plus is the smallest bivalent cation. It accommodates larger number of water molecules. So here 8H2 is stabilized by this particular magnesium halide, and in case of calcium chloride it only accommodates 6H2O, and strontium chloride it exits only 4H2O or 6H2O depends on the structure, and this barium chloride only accommodate 2 water molecules. And barium chloride actually contains 2 water molecules. What does it mean? Barium 2 plus actually it has very large size compared to that magnesium 2 plus. So it has less tendency to accommodate water molecule, or you can simply say barium 2 plus undergo less hydrations because of the large size. So it only accommodate 2 water molecule in this particular crystal lattice, right? So that is why, because of the hydration number decreases from top to bottom, so the solubility decreases from top to bottom. So solubility decreases as hydration number decreases, right? So this is the actually beauty of this particular halides. And most important applications of like calcium CaCl2, that is calcium chloride. Most important application in the cold countries. Actually, in the cold countries, what happens? Actually, on the roads, ice, actually they are freezes, means water, they freezes on the roads and blocks the transportation facility. So in this case, actually, a 30% calcium chloride and H2O, right? So if this particular eutectic is used in the cold countries to melt the ice on the roads, they are actually depresses the freezing point or melting point of the ice. So it freezes water at minus 55 degrees centigrade. But in case of NaCl, right, and H2O eutectic, right, it only allow to freeze water at minus 18 degrees centigrade. So this particular like alkali metal halides or alkaline metal halides, they are used to melt the water in a cold countries. So because all these compounds lowers the melting point of ice, or you can say the freezing point of the ice is lowered down or depresses, so it will freezes at very low temperature and roads are vacant and the transportation facility is actually easy. So they are actually most important for the practical life in systems. So these are the aspects, chemical aspect actually used in various sectors in the cement industry. So also in the glass industry also actually they are used. So this is actually what they are the chemistry here. So thank you students for listening and watching this particular lecture, especially on the highlights of the alkaline earth metals. So I think, not only I think, but I hope this particular video lecture would be beneficial and actually inspiring, influencing to your minds, and hope you won't forget to like, share and comments on this particular videos, right? So thank you so much.